Alright, let's consider the redshift in Doppler effect. Now, we're using the redshift saying we must prove that the universe is expanding. Then, when we need, so let's have our universe here, which is our world. Then on this world, which is Earth. Now we have an observer here, an observer on the Earth. Now, if you're observing a star from a distance, now this star is going to shine. Now, what is happening? This star will shine towards the observer. Then, how is it shining from the observer? Then it's showing a light. So obviously a star will show a light. But when the observer look at the star, let's put in years. Let's say maybe from 2005. What we believe, because the star is not maybe shifting the position, but we know also the Earth, let's say, it's not shifting the position, but the observer is looking at the star. Then the light is traveling in terms of the wavelength. So let's take the wavelength from this star to the observer. So they'll be moving like this. Then let's say this star will record a frequency of 100 hertz. So the frequency are measured over the hertz. But after some time, this is now 2023. The same star and the same observer. Now chomo level, let's say record a frequency of 80 hertz. Now what we believe going, if ever 8 hertz roaring, it will some changes. So what frequency fukuje ogoncharing this star ogonchagare movile away. Remember frequency adna re kana in terms of heat, but gam hora re be fishe ka ona gam go be se bona la ka ona or se as change it, but ora se ka ba se movile away. Then as move away from this roaring, it means we're going to have a different wavelength. Then we're going to start says shift from this position to this one. And now the wavelength from the same observer to the star right now is going to change. So from this one, the wavelength is changed. So what change it? Then we say this eventually the star is moved, shifted away from the observer. I mean, as shift away from the observer, so running moving away from the observer, which is away from the universe, and then overall the universe is movie. Then the star will appear different. Running eventually, if the frequency is decreased, but the wavelength is increased, eventually the relationship between the wavelength and the frequency is an inverse relationship. So running or stars is from the observer or a different wavelength so expanded. So this wavelength is now expanded. So expandile, but the observer will still see the star, but the seems like the star has changed color. Now the colors we had, they were like this weak beef. So mara using this theory, Oraroshimisha only two, the red at this point and the blue. or whatever that it is moving towards the right, we call it to the blue shift. So that's globally the red shift and the blue shift. Now, from this theory, our frequency is decreasing if we're approaching red. So what it means, the wavelength increases if we're approaching red, but when we're approaching the violet or the blue color, then it means the wavelength decrease. So the same part saying if the wavelength decrease, the frequency increase when we approach the blue color, then it means the frequency this side will decrease when we approach the red color. So it means when we observe this star as it's moving away, it means the wavelength here is increasing. So when a wavelength is increasing, then we're saying it's moving towards red. Then that's why if it's moving, the star is moving away from the universe, then you say it's moving towards the red. So rather a mover towards the red, rather we call it a red shift. A red shift, so because it shifted towards the red. Then if the frequency was increased, then meaning, or if the star moving towards, this is away, if the star's moving towards the earth or the universe, it means we're going to increase the frequency. So if you increase the frequency, it means we are moving towards the blue. So already the blue, you can say it's moving, the star will be moving towards. But when I say red, the star is moving away from the universe. So that's why they concluded that when the star moving away from the earth, then it's doing redshift, and then when it's moving towards the earth, it's doing the blue shift. So as like you observe in nature, the stars that are appearing to be red, they'll be very small, then it means they are very far from the earth. Then the ones that are very close, they are appearing like a blue color. So that's what they concluded using the Doppler effect theory. Now we have the spectral lines with the color, and this can be the initial or origin. So these things can be done in the lab, and then now after that we'll have a distant star. A distant star. So meaning this is what the observer will observe initially, and then what is it? So let's put the lines here. Then let's say we have these lines, the spectral lines like this, and then normally they'll put the colors or the wavelength. So if it's the colors, they can put the red here and then the blue this side. So if Bashumisha the wavelength, so running this side, we must have a bigger number of wavelength. So maybe regarding can be say, let's say 650 nanometers, because this one will be very starting from or the blue one is having a lower wavelength, so we can have around maybe 405 nanometers. So this, if they are given in numbers, the one which is lower ya fast or ya blue. The one ya high value on the meters or it over red. Right. Then this is a distant star after some time. I'll click origin, the first observer. Then after some time, then now let's say we're going to observe the spectral lines being like the same spectral lines will be appearing like this. And then we still have the red this side, blue this side. Then from the distant star, or this happen after some time. So they will need you to compare these two, or what is the shift. Now, our level from the origin, that is done in the lab, they can say the lab or from the origin. So this is what is observed from the origin. But after some time, which is a distant, they call it a distant star, there is being a transformation or a movement here. If you check, or this spectral line, we call this a spectral line, move from here to here. Move from here to here, from here to here. So what the observer or the mover towards red. So what the mover towards red, then that's what they will ask you, what is the phenomena, or what is the kind of shift that is happening. So if they're moving towards red, these lines, the new lines are moving towards red, shift, or if above the colors, then they'll talk about the numbers. So but you can observe that they are moving towards 650 nanometers. So what it means, we will say now this is a red shift, a red shift. And then if they say the reason, you'll say the spectrum moves towards the longer wavelength, or to moves towards a shorter frequency. So it depends on the explain the frequency or the wavelength. So if it's in terms of wavelength, we'll say the spectrum lines reason, we'll say the spectrum lines moves towards the you can say towards the red shift, or towards the red, or we can say they are moving towards a longer wavelength. If it's a longer wavelength, it means they are moving towards a shorter frequency. If you measure frequency, you say shorter frequency, because remember, if it's longer wavelength, it means the frequency is shorter, because they are inversely proportional, the wavelength and the frequency. Right, meaning now the red shift is a shift when the spectral lines move towards the shorter frequency, and yeah, they move towards the shorter frequency, and then, or we can say they're moving towards the longer wavelength of the observed from the observed spectrum. So that could what you could say about the red shift. Let's get example questions. They're saying a study of spectral lines obtained from various stars can provide valuable information about the movement of the stars. So because the stars are moving, we need to know whether they are moving towards or away from the earth or from the universe. The two diagrams below represent different spectral lines. This is what we are saying of an element. Diagram 1 represents the spectral lines from the element in a laboratory. See, a laboratory on Earth, which is the origin. The diagram 2 represents the spectrum of the same element from a distant star after some time. So now you know that this is the origin. So from the information we're trying to identify where do we start, and then what is the result after, and then this is after, which is a distant star. Now this is the two diagrams. Now let's observe the origin. These are the spectral lines here. They are now here. Now the blue kamoke red. So we check the shift lagai. Now after that level, this line imovile towards this one imovile, the second one move back, move towards. So all these lines, the spectral lines, you can see that are moving towards blue. So this is going to be a blue shift, and if it's a blue shift, it means it's now moving towards the Earth. So it's coming closer to the Earth. The stars coming closer to Earth. So, but let's get the question. Is the star moving towards or away from the Earth now? We have the answer is that it is moving towards the Earth. Then they must say explain the answer by referring to the shift of the spectral lines in the two diagrams. So we simply say spectral lines, the spectral lines or the spectrum lines moves towards the blue shift. But the important part is that they are moving towards the blue shift or the blue color or the blue spectrum from the observed one. So that would be your 2 marks, but choosing towards, and then why are you saying that? So observing the mover towards the blue shift or the blue spectrum. Right, that's what we can say. Example number, this will be number 1. Number 2, there's a use your knowledge of Doppler effect to explain redshift. So we said the redshift, you can check the exam guideline, that is exactly the same definition, but we said the redshift occurs when the spectrum lines, so the redshift occurs when the spectrum or the spectral lines moves red supposed to be moves away it's when the spectral lines moves away from they're moving away from. Now we need to decide whether we talk about the frequency or we talk about the wavelength. So it means they will move away, they're moving away from or moves towards. Let's say when the spectral lines moves, let's use towards longer wavelength, moves towards a longer wavelength of the spectral lines moves away or moves towards a longer wavelength of the distant star. So rather the key that they are moving towards longer wavelength. or they are moving away away of a shorter frequency, or move towards a shorter frequency of the distant star. So, but what is moving? The spectral lines moves. Which one are using? Towards the longer wavelength or towards the shorter frequency of the spectrum lines. So this is what we can say about the explaining the redshift. So it's about where the spectral lines moving towards or away. Now, number 3, they are saying the spectral lines of a distant star are shifted towards the longer wavelength of a light. Then is the star moving towards or away from the Earth? Now they're saying spectral lines of a distant star are shifted towards longer wavelength. Where do we get longer wavelength? From our REDSHIFT. The longer wavelength are towards the red. So if it's the red light, then it means it's moving away from the Earth. Then we simply say away from the Earth. So the reason it's moving towards the longer wavelength. So this gives us the definition of this redshift, because we said it's moving away or towards the longer wavelength. So this, we can say the spectral lines of a distant star are shifted towards or moving towards a longer wavelength of a light, or they are shifted towards a shorter frequency. If you're not saying wavelength, I will say shorter, a shorter frequency. Right, this is how we can answer the questions about this redshift or the blue shift. So the next question, they are saying number 4, let's just read. An observer of the spectrum of a distant star shows that it is moving away from the Earth. It's moving away from the Earth. This is the keyword. Explain in terms of the frequencies. Now that you are forced to use the frequencies of the spectral lines, how it is possible to conclude that the star is moving away from the Earth. Now this is the keyword. How say it's moving away from the Earth? Now they're saying shows that the star is moving away from the Earth. So what is the frequency there? If it's moving away from the Earth, then away from the Earth, what you can explain? How is it possible? So we'll explain using the frequency. So saying it shows that the distant star or the spectrum of a distant stars are moving towards a shorter frequency. So if it's a shorter frequency, then now you're telling them that it shows that it's moving away from the Earth, where we have a shorter frequency. We're going to now observe a shorter frequency than the one observed before. So simply tell them that the distant star or the spectrum of the distant star is moving towards a shorter frequency of the spectral lines. So you get your 2 marks for saying that. Last one, they say the spectrum of a distant star when viewed from an observatory on Earth appearance to have undergoing a redshift. Explain the redshift. So we've done that. So you can explain your redshift in simple ways of using the wavelength or the frequency. So that is what we have for these questions.